Let's look at problem 59 from Project Euler, XOR decryption. So each character on a computer is assigned a unique code, and the preferred standard is ASCII, which is American Standard Code for Information Interchange. So for example, uppercase A is mapped to 65, asterisk to 42, and lowercase k to 107. So each character on a keyboard, or in general any ASCII character, is mapped to some ASCII integer value. Next, a modern encryption method is to take a text file, convert the bytes into ASCII, and then XOR each byte with a given value taken from a secret key. The advantage with the XOR function is that using the same encryption key on the cipher text restores the plain text. For example, 65 XOR with 42 outputs 107, and if we again take the XOR with the same secret key, we are going to end up with the same input that we started. So if we take XOR even number of times, we get the same output. So that is the case here. We take the XOR with the input sequentially one after the other 2 times, and we end up with the same input that we started. For unbreakable encryption, the key is the same length as the plain text message, and the key is made up of random bytes. The user would keep the encrypted message and the encryption key in different locations, and without both halves, it is impossible to decrypt the message. So unfortunately, this method is impractical for most users. So the modified method is to use a password as a key. If the password is shorter than the message, which is likely, the key is repeated cyclically throughout the message. For the balance for this method is using a sufficiently long password key for security, but short enough to be memorable. So initially this 65 was our plain text or original input, and 42 was our key. But if the length of the key does not match with the length of the input, we are going to cyclically repeat the key one after the other, the ASCII values. Here it was only a single integer value. The length is 1 here because it is a single integer defining a single character. But if we have a string of length 100 and key of length 3, then we need to cyclically repeat the key one after the other as long as sufficient input is available, and we need to perform XOR for each of the corresponding key and input. That is what they have mentioned here, and the task that they have given us is to find an encryption key consisting of 3 lowercase letters, and they have also given us a ciphertext file. So this is the ciphertext file, which contains comma separated integers, which are the ASCII values of encrypted message. So this is not the original message. If we convert this to ASCII and print it to the output, you will see that it does not make any sense. It does not contain any common English words or meaningful paragraph. So this is the encrypted one. We need to find a key for which, after decrypting this text with that key, forms a sequence of characters which consists of some common English words. And if we found such a paragraph, we need to find the sum of the ASCII values in the original text. So that is the question. Let's also go over it in simple terms. So there exists some key of 3 characters. We don't know it yet. We need to find out this, and using that key, we are going to decrypt the given sequence of ASCII values of original text with this key. And this decryption is going to produce the original text with some common English words, as they have mentioned, because the starting text or original text was fixed, and they have encrypted it with some key that we don't know yet, and they have given us the text in the form of this is the representation of those ASCII values of encrypted text. And using that, we need to decrypt it with some key of length 3, and if we find some paragraph with meaningful words and sentences, we are going to say that that is the original text, and we are going to find the ASCII values of all the characters used in that text and print the sum of that. So let's also go over in detail what this decryption process is going to look like. So the first step for the decryption is to fix some key k, which consists of 3 characters C1, C2 and C3. And since they have mentioned that the text consists of common English letters, so we can assume that there is at least one word in that whole paragraph which is a small word, such as is, the, and, then, that, similar, and it consists of lowercase letters. So we can fix these 3 values by using a naive approach. We can say all the possible values that C1 can take is up from A to Z, C2 can take is from A to Z, and similarly for C3. And this is the value that we have fixed for some particular key k. Once we fix that k, then this was our input in the form of integers, was the ASCII values of original encrypted text. And after decrypting it with the XOR, we are going to cyclically perform the XOR operation. So first 3 values will be XORed with the first 3 values of the input, then the next 3 will again be XORed with the input in cyclical format. So the formula comes out to be the decrypted text at ith position will be the encrypted text at ith position XOR with the key at ith position mod 3 plus 1 for the 1 best indexing. So this is the general idea for cyclically performing the XOR operation for decrypting the text with some fixed key k. So after this step we are going to end up with some decrypted text, and this is again the integer representation of the number. So first of all we need to convert that ASCII to character, and we arrive at a sequence of characters formed which should contain a meaningful English paragraph with common words. So after converting each integer to character, we are going to be arriving at a sequence of characters, ASCII characters, and we can verify whether this sequence contains some common English words like the, and so on. If found, we can simply print the ASCII values of such decrypted text. So this was fairly straightforward approach, and let's also go over the solution in brief. So first of all, we need to create and iterate all the possible keys C1, C2 and C3. So C1 can take 26 values, C2 can take 26 values, and C3 can take 26 values. For all of these permutations, we are going to start off with the key k, considering all possible choices for C1, C2 and C3, and decrypt the input text as we saw in the 2 steps earlier. After that, we are going to check that whether the decrypted text contains some common words like the, and, or, is, and if found, we can simply print the ASCII value of that text. It was a fairly easy approach, and this is a fairly simple question, so I am going through this quickly. Now let's go over the C++ implementation. So we have the main function. We simply going to read the ASCII values from the file in. So I have copied all the comma separated values, converted them into space separated, and stored them in this file named in. We are going to read it from the standard input in the read only mode using FREOpen function. So cin is going to read one integer from this file. So as long as we have some integers, we are going to store them in this input, which is the encrypted text that they are giving us as input. So this will store all the inputs from the file. Next, we are going to iterate over all the possible keys that are going to be fixed for some particular key, which is from A to Z for each of the 3 characters C1, C2 and C3, and the key is then again converted into an integer. So you can see that this is a character, but it is typecast to integer because this is a vector of integers. So this vector will contain the ASCII values of these corresponding characters, and this result will be the decrypted text. As we saw earlier, the formula turns out to be index of the encrypted text XORed with the key of the same index mod 3, because we are going to cyclically repeat the key one after the other. And this is the ASCII value that we get after XORing with the two fields, and then we can simply add the character representation of that ASCII value in the result. After that, you can check whether this common word such as the, which contains space on left and right, is present in the result string. If it is present, we can simply print out the answer and sum up the ASCII values and return the answer then and there. Yeah, so that was it for this video. It was fairly straightforward and a simple problem. So yeah, see you next time.